So today we discuss photoelectric effect. That's a very important concept to discuss. Photoelectric effect. Okay. So what is photoelectric effect? First we draw a diagram. A discharge tube for understanding we must be draw a diagram. Okay. So here is a discharge tube. There is some window here. Okay, and there is a two electrode here. Okay, one, these two electrode, and these two electrode connect to some commutator, and its commutators look like this. So here and here, these are, and now look like this. Okay, there is a voltmeter here for measuring potential, and there is a current meter for milliammeter, okay, measuring current, and there is a battery, okay, and this for variable obviously, so that's where, okay, and these two electrode obviously is photosensitive, must be this plate, okay, this plate is photosensitive plate, photosensitive plate, and name that plate is this plate is called plate C and this plate is called plate A, and also this plate is another name, it's called emitter plate, and this is called acceptor plate. Why this plate is called emitter? That's very important. Okay, so actually later we discuss why this called emitter, why this called acceptor. Okay, so further discussion. Okay, so what is a photoelectric effect? Before we discuss the photoelectric effect, we need the emission discuss. The photoelectric emission. So Heinrich Hertz in 1887. Okay, actually he observed that a high voltage spark, okay, across a detector loop. Okay, these are called a detector loop. Okay, detector loop, and were enhanced when emitter plate was illuminated by UV light. So there is some UV light source here. There is a UV light source and fall on this light in emitter plate. Okay, and when these UV light fall on emitter plate, and this plate have some, because this plate is photosensitive plate, so obviously this plate have some free electron, and this free electron get some energy with the help of light. Okay, so another two scientists, Holloch and Leonard, so say the Holloches or Leonard, okay, these two scientists, Holloch and Leonard, observed, so some current here. Okay, so first Leonard observed that when UV light falls on this photosensitive plate, okay, or call this emitter plate, okay, falls on emitter plate, and there is some current. When Leonard observed, if UV light falls on the emitter plate, so there is a deflection here, there is some current, and the Hertz observed that the metal have free electron. Okay, this Hertz said that the metal have free electron. So if that when UV light or UV ray falls on the metal surface, so their free electron escape from metal. So if metal have free electron and this electron and some energy from accepted from UV light, so this electron now free and escape from metal. So that's why this plate is called emitter plate. They emit electron. Okay, the C plate is called emitter because they emit electron in surrounding. Okay, these are the electron. Okay, so an electron has some negative potential here. Okay, and actually escape from metal. So these electron absorb energy. this electron absorb enough energy. Energy means not only some enough energy from UV radiation to overcome the attractive pull. So what is the attractive pull? Because it is like that, when metal, suppose consider like a sodium, suppose the sodium is a metal, okay, if sodium electronic configuration is 281, okay, if one electron loss escape from sodium metal, so sodium get a positive ion and electron are negative ion. So these two are plus and minus or opposite polarity. If this plus and minus, the metal have now emitter metal plate have positive and these electron are negative. So there is some attractive pull here because they are unlike charges. So there is the attractive pull. So we need the enough energy to accept that electron to overcome that attractive pull. Okay, clear? So enough energy need to overcome that attractive pull. Okay, that's Leonard actually said that when a UV ray stop, the photoconductor stop. No UV ray means no current. So when this electron, okay, this free electron accept some enough energy to overcome that attractive pull. Okay, and now there's the free from metal. Okay, so that's why this UV ray, the electron accepted some energy gain with the help of UV ray. Okay, because these are the material have that photosensitive material in. Okay, these C plate have photosensitive material, means the energy from light with help. Okay, so when you need some apply electric field. Okay, so Leonard say that is there is a plate, so there is a battery. So now we apply some field. Apply some electric field. Okay, so here acceptor plate we apply a positive potential and emitter plate we put here the negative potential. Okay, so there is a electric field in that direction. Okay, if there is a electric field, so electron or free electron actually, those electron escape from metal now move in acceptor plate direction or collector plate direction. Okay, so if I again draw the diagram, you see that. Okay, so in that direction. Okay, okay, now here is the important factor. When you apply the electric field, actually where we apply electric field, and now this field are moving in that direction. Okay, here that plate here and this electron move in that direction because the electric field in that direction. Okay, there is some emitter plate or C plate and this called acceptor plate. Okay, so there's some electron emit from the plate and move towards the plate A. Electron emit from emitter plate and move towards the acceptor plate. Okay, when we apply some electric field like that. Okay, concept like this, that and get some current here. Okay, and now further study the Holloch. So now that name came from Holloch, and Holloch study that is zinc plate. If I put a photosensitive zinc plate here, Holloch said if I put a photosensitive zinc plate here. Okay, so the emitter and input in emitter plate, okay, in zinc, and this zinc have lost electron. It's actually observed that zinc have lost electron, and if a zinc lost electron and gain positive charge, If zinc is lost electron and zinc get positive and electron get negative charge, and already basic electron with a negative here. Okay. When apply a UV ray on zinc plate. In 1897, further studies in 1897. Okay. So they observed that emitted electron from C plate moves towards the plate A. Okay. See the emitted electron from C and move towards the A, and actually accept plate A. They observe number of electron are emitted at all. Some we need some frequencies here. Okay. So electron moves here. So he observed that so there is some UV light here. So light have some frequency here. So number of electrons are emitted at all when the frequency of incident light minimum value. Okay. So UV light have frequency, and they observe in 1897. Actually, they observed that UV ray, all UV ray falls on emitter plate are not possible to overcome that attractive pull. Okay. So some minimum frequency must be needed. Okay. Some minimum or cutoff frequency must be needed here to overcome that attractive pull. Okay. Actually, electron accepted that energy from UV light, and this overcome that attractive pull. If I put a suppose say that is a 1 kilohertz frequency of UV ray, and we say that attractive pull is greater than 1 kilohertz frequencies. Okay, the energies here. So that's why these electron not overcome the attractive pull. So there is a minimum frequency must be needed here. Okay. So incident was a smaller. Okay. Some incident ray was smaller than some certain minimum value. Okay. If a smaller than minimum value must be needed. Okay, must be needed. So here we need the number of electron were emitted when UV ray have more than some fixed value, more than some fixed value. Okay, and these some fixed value. Okay, frequency. These values frequency. Okay, we here discuss frequency. So if UV ray have some more than some fixed frequency values. Okay, and this frequency is called threshold frequency. These frequencies is called a threshold frequency or frequency. Is lesser than threshold frequency. If UV ray falls on emitter plate is lesser than threshold frequency, so no electron was emitted from metal. Okay, so if we need to electron escape from metal surface, that frequency of UV light is must be greater than threshold frequency. Clear? The minimum frequency depends on the nature of the material. That's the minimum frequency. Threshold frequency here, that is the minimum frequency must be needed. They say that the minimum frequency of UV light or incident radiation must be needed. Okay, this minimum frequency depend on the nature of the material. Okay, and that this threshold frequency depends on nature of material. Clear? And this must be needed for if UV ray frequency of UV ray is greater than threshold frequency, so we get photoelectric effect. We get photoelectric effect. Clear? So there is some plate, emitter plate here. So there is some emitter plate have suppose zinc. Okay, suppose cadmium. Okay, magnesium. Okay, so has a good UV ray in short wavelength. These are very good in UV ray. Good in UV ray. They actually good response in UV ray. Okay, so they are short wavelengths. Short wavelength. Good response in short wavelengths. Okay, and some alkali metal. Alkali metal. Actually, I discuss this metal only for emitter plate. Okay, this discuss only for emitter plate. Okay, emitter plate. Alkali metal here, suppose lithium, sodium, potassium. Okay, cesium. These are the alkali metal. Okay, are good also sensible in visual light. Okay, these are also sensible in visible light. Actually, good in visible light. Clear? So now the threshold frequency is very important. Okay, UV ray, actually incident radiation of UV ray, we need must be greater than threshold frequency. That's the minimum frequency must be needed to get some photo current. Okay, so here this substance is called photosensitive substance. We needed a photosensitive substance. It is substance. Okay, and this electron, actually the electron like that, this electron, those electron are freely escape from metal, and this UV light frequency of UV rays must be greater than frequency of threshold. Now this electron is called photoelectron. It's called photoelectron because actually this electron get enough energy to overcome that attractive pull from UV ray. From UV ray, that's why this electron is called photoelectron. Okay, and this we get some current here. When these electron are accepted by that acceptor plate or collector plate, so now we get some current here, and this current is called photocurrent. This current is called photocurrent. Okay, when electron released from C plate and move towards that acceptor plate or acceptor plate or collector plate, we get some current, and that current is called photocurrent, and that electron is called photoelectron, and this frequency of UV radiation must be greater than threshold frequency. The threshold frequency is minimum cutoff. Okay, and this all phenomenon is called photoelectric effect. This all phenomena is called photoelectric effect. Clear? What is photoelectric effect? Now we discuss the experimental study of photoelectric effect. Now we discuss experimental study of photoelectric effect. Okay, so here this current, this meter gets some current, and this called photocurrent, and this photocurrent depending on some factor. Okay, so depending on some factors, and the factors are, first factor is called the intensity of UV light or incident radiation. Okay, intensity. Second factor, factor number 2, frequency. of incident radiation. Factor number 3, potential difference. Here we apply electric field. Okay, that's the electric field. Electric field or potential difference between two plates, between collector plate and emitter plate. Collector plate to collect the electron, photoelectron, and emitter plate, those emit that photoelectron. In between these two there is some light here. Okay, and fourth point is okay, nature of material. Nature of material. When I say that nature of material means in emitter plate. Okay, and this plate must be photosensitive plate. Okay, so today in the first part on photoelectric effect. Okay, so next class we discuss photo current depending on some factor. Okay, next class we discuss how the photo current depending on that factors. Okay, so intensity, frequency, electric field, and nature of the material. Okay, so today in the class here. Thank you.